Okay, you're going to write a series of steps in your note. In mind, let's go back and look at our experiment. And the first thing that happened is that we had our top of our bottle, these gas bottles they're called, had a lot of oxygen. It actually had pure oxygen in it. I made that for you. And we brought our deflagrating spoon into the bottle. The carbon reacted with the oxygen, and we made our carbon dioxide. Okay? Oxygen would be attracting those electrons, and this oxygen will pick up a carbon, and we're forming our carbon dioxide. Okay? And that was when you had that light spoon in there. So now let's go back to this picture here. This massive picture here on the left is a representation of what's going on in this gas bottle. There's my carbon dioxide I produced from burning my carbon. Here's my liquid solution with my BTB drops in it. 1, 2, 3, 4, 5, 6. I've got my 6 BTBs in here, and they were blue, so I know it was negatively charged. And the swirling was allowing this carbon dioxide to come into the water solution. Okay? Carbon dioxide is coming in. Carbon dioxide is starting to dissolve into this liquid environment. The carbon dioxide reacts with water, and this is what happens to it. That carbon dioxide comes over, bonds to that, and that happens. That's the chemical formula for that.
All right.
And the name of this is carbonic acid. Carbon has a difficult time dissolving in water. Okay. And if it does dissolve in water, not all the carbon dioxide forms carbonic acid. And actually, that is the reason that we call this carbonic acid known as a weak acid. It's not a strong acid. Okay? The next step that happens is it's really cool what happens to carbonic acid. And what I just did with my hands, when hydrogen leaves that carbonic acid, we actually use the language dissociates. So, whatever step you're on, a hydrogen ion dissociates from the carbonic acid. Now the language it says it's carbonic acid. What does Arrhenius say makes something an acid?
Hydrogen ion?
Hydrogen ions. So the reason carbonic acid is called carbonic acid because it has the ability to produce hydrogen ions. Yes? By this incredible new thing you just learned today, dissociation. It dissociates. Okay, but what color is my solution? Right now, on the board.
Blue.
It's blue. BTB, it's negatively charged. This is positively charged. Okay, ready? Next step. The BTB attracts a hydrogen ion. Watch what happens. It attracts it. BTB, flip move. Now becomes yellow.
It dissociates
From the
carbonic acid.
Good. Okay, we're gonna.
And-
Okay. Good. Okay, BTB is attracted to it. Okay.
I don't know what I'm saying.
I know you don't. Wait, I totally get it, right? We
Yeah.
have to practice the articulation. Okay, that's great. I'm going to add another piece of language to this. If this was originally carbonic acid, okay, it lost a hydrogen ion, which is a positive charge. That means this thing is now negatively charged, and it has meaning. Okay, we're going to call it. Yes, we are. A bicarbonate ion is formed. That's it's a polyatomic ion.
Yeah. There's a market.
Now sometimes we can have two hydrogen ions dissociate. Doesn't happen a lot with the weak acid. If two hydrogen ions dissociate, now my charge becomes 2 negative. And what type of ion is this?
Carbonate, man.
You better hide. Yeah, I just took that all away from you. But I've now formed a carbonate ion. This hydrogen ion is going to get attracted to the BTB. Great. Okay, BTB becomes yellow. What color is our solution right now? A little bit more to the yellow side. All that meant was that you had a really good burn, you got lots of carbon dioxide, you were able to dissolve lots of carbon dioxide, and you got more BTB, you produced more hydrogen ions, and more of the BTBs turned yellow.